Okay, so I'm going to show you how to do ray diagram for lenses. So first, let's start first with convex lens. So our given are the following. We have the distance of the object, 7 centimeters, focal length, 4 centimeters, and the height of the object, 2 centimeters. So using your ruler, you have to draw first the principal axis. And then you need to mark the important points. You have to mark the vertex or the optical center of a lens. And then after that, since this is a convex lens, we will be using the opposite side of the lens or the positive side of the lens. So from the vertex, we need to measure first the focal length, which is 4 centimeters. So using our ruler from the vertex, we will measure our focal length so that we can measure or mark the focal point. So here is our focal point. Okay, and then if we're going to double the value of our focal length, so 4 times 2, we will have 8 centimeters. So that marks our twice the focal point or twice the focus. So let's have it here. This is our vertex. This is our positive focal point or focused. And this is our positive twice the focal point or 2F. Now we do on the other side also. Let's have our label on the other side of our diagram. So let's measure again the focal length to mark our negative focal point here. And we double the value of our focal length to mark our negative twice the focal point or twice 2F. Okay, so we're gonna label this marks here F, prime F, negative focal point, and here let's have negative twice the focal point. Okay, so once you have these markings, okay, the next thing that you need to do is to draw your lens. So this is a convex lens. So let me draw the lens. And sometimes the drawing of our lens is not perfect, but to solve that problem, we can draw an imaginary vertical line here that crosses our vertex. Okay, you can use dashed lines or broken lines here to represent this vertical line. So this will be our basis on when can we bend or refract our ray. Okay, so if we have this, the next thing that we need to do is to measure the distance of the object. So from the center, okay, of the lens to this side, we will measure 7 centimeters. So using our ruler again. Okay, so this is the distance of our object. Okay, since the height of the object is given, it is 2 centimeters, so we will measure that using again our ruler. So from the principal axis, okay, so this is now our 2 centimeter. So let's use an arrow to represent our object. Okay, so if we have this, we are now ready to draw the rays. And remember, for ray diagram for lenses, there are 3 rays that you can consider. We have the PF ray, we have the FP ray, and we have the VV ray. And remember, these rays here will be your incident rays or your incoming rays, and this rays here will be your refracted rays. Okay, so what does it look like? What does PF ray look like for convex lens? So you have to draw from the tip or the head of your object. You draw an incident ray that is parallel to the principal axis. Okay, and then it will be refracted, okay, bended, passing through the positive focal point or focused. Okay, so this is what it looks like for your PF ray. Now we're going to pair it with the FP ray or VV ray. Again, for ray diagram, you can use at least 2 rays. Okay, so let's have FP ray here. For FP ray, okay, an incident ray that pass through this negative focal point and refracted or bended, okay, refracted and bended parallel to the principal axis. So as you can see, our refracted rays intersect here on this side of the lens, and that side where they intersect, okay, that is actually the point where the image is formed. Okay, so from the principal axis to the merging point of the refracted rays, since it's below the principal axis, the image will be inverted. You draw the image that it is inverted. Okay, now if you will measure, okay, the distance of the image using your ruler, okay, let me use my ruler to measure the distance of the image. So here, the distance of the image, okay, is equal to 8.7 centimeters. And for the height of image, using my ruler, we can measure the height of the image. So this is 2.5 centimeters. Okay, so this is how you can do ray diagram for convex lens. To add more, you can also use the V-ray. When we say V-ray, the ray pass through the vertex or the optical center of our lens. So it will look like this, following the law of refraction, where the angle of incidence is equal to the angle of refraction. So there you go. Your V-ray looks like this. Okay, so but for ray diagram, at least 2 rays will do. To describe the image form here, okay, using the acronym LOST, for the location of our image, this is our image. Okay, location of the image, if you will look at the points here, it's located beyond 2F. So you could say beyond 2F. That's the location of our image. For our orientation, if you're going to compare the orientation of our image to the orientation of our object, it is actually inverted. For the size of our image, since we were able to measure the height of the image here, which is 2.5 centimeters, comparing it to our height of object, which is 2 centimeters, we could say our image is enlarged, okay, or bigger than our object. And for the type of image, since our image is inverted, okay, our image is real.